So this is part six for speech system interaction, and what we are trying to implement today is uh, we need to do a multiprocessing. So why we need it? So previously, as I've defined that I'm gonna speak some particular keyword, uh, either in the entire sentence or the specific keyword it's going to detect, and then whatever I'm going to ask after that keyword. This keyword we are here we are using Shana. But after that keyword, it's just going to detect my command, and according to that, it's going to give a response. Now, considering the fact that if we don't like we ask for to start a timer for 20 minutes, let's say, for that 20 minutes, it's stuck there and it's not going to listen for the next command. But within 20 minutes, there are high possibilities that you're going to ask for something more, just not just your timer thing or something, right? Considering that scenario, what I've came across is to actually uh, make it available. Meanwhile, it's going to just run one process. So by that, we come to multiprocessing. So multiprocess is basically handling, helps you out to do first thing that use your cores. So CPU have cores, 4 cores, 6 cores. So need to use those cores and once as more efficiently, and we're just allowed, I think, 10 16%, 16 or 10%, I'm not sure with the count, but some amount of our entire processes, guys. There are a lot of processes that keep on running. So like right now, this display process is actually running at the back end to give me that display. So there are a lot of processes that always run by themselves. So then you're gonna work also. So there is a lock to run minimum amount of a maximum amount of process at once, but we have multiprocessing to actually overlook that and actually do something which is kind of required for us in such scenarios. So if you're dealing with speech, we don't like it that if I ask to create a timer and then it's just gonna create a timer and then gonna wait for that timer to complete and then come back to listen for my next command, which is completely not good thing to do. Like consider you ask your Google to create a timer for 20 minutes and then it's actually going to wait for that 20 minutes. That we cannot do. Secondly, uh, in other way, we have different applications that we can trigger a give a variable, and then we are done with them. We those are independently working on them. It doesn't need anything. But in this, it's everything done by one under one roof. So that is a problem. That time we need multiprocessing to deal with. So what I did is actually I created two options to to jobs actually to do it, to implement multiprocessing just for a small instance. I haven't implemented or like integrated this with the previous tute yet because I'm still like testing stage because there are almost stuff that we have to deal with before um, adding or implementing the same logic in the main program. But I created two functions. So coming back to this, two functions. One is China, other one is simple hey. So these like completely referring to the string that I'm going to say. If my phrase has hey or Shana, then the respective defined function will run. Then this is actually a way that we can simply create a multiprocessing and processes, and we're going to give a target. Target is basically the defined function that we're going to give a target. If you want to pass an argument, there's also an option to define an argument and then equals to, and then you can define particular argument if you want to give it. Then about that we have one thing that I have commented out here, that is speech join. So this is actually an important thing because I'm just going to talk about more on this also, but I'll give you a initial start for this. Speech join is actually going to wait, like this process is start, I said hey, and this process is start, but it's not going to run for others if I am going to say speech join. It will record, it will add into memory. Even if I say Shana, it's going to store there, but it's going to actually wait for this process to complete, then to jump on another one. or even start another one. So that is not we want in this scenario, because 20 minutes delay, okay, let it be, but you need to be available for the next command too, and should be able to actually start implementing that, right? So for those scenarios, we just cannot use pjoin. We have to be very sure that we are not going to deal with that soon. But like if you're going to terminate it or something like that, then yeah, pjoin is needed, because then every process is supposed to be end at last. So you can go a kill or something. So for like depth understanding, which for me I had to go like week. I'm a day job person, so yeah, took me a week. But this is actually a really helpful document. You can, it's already available in the docs file, so you can just go through this and try to understand what all methods and some methods and defined functions we have for this. I really like pool. Till date, I've used pool. Queues is a good thing, and pipes is a good thing. So queues and pipes are actually, it's like queue is basically, you can understand with the name. It's a good way to actually do it. So I'm going to try to implement for the further instances, because there are some like in the thing that I've implemented here, it's gonna work for those where the process is completely independent with each other, like getting a weather report and starting a timer. These are two completely independent. One is completely dependent on the weather details that we have for the upcoming days, or for the day on which it was being asked for, and the other one is completely like a timer. It's working on a time duration. That's different. Two different things, two different processes, not dependent on each other anyway. So queue or pipes, these are not needed in such scenarios, but there may be a possibility that you need to deal with, like calendar entry or something. So that I can go in a different, deeper way, but that would be for the tunes. So basically, I did like for the phrase, I did an if and else for an instance right now, that if I have this, then do this, and if I did this, then do this, right? This is a way we can use a DB and get it into a single line and then keep on running it. That is also a way, but for now. So I did run this and I get a response. So this is the thing that actually happens. So first thing that I said is hey, and this is hey, the define function, which is actually a start line for hey, right? This is from, and then it went for a time sleep for 10 seconds and it doesn't wake up. Meanwhile, I'll do a lot of stuff. I said China, then this print line statement was executed. Are you there? Doesn't have a hey, so hey or Shana. So hey and Shana was not there, so it jumped to I don't know what you said. Then listen, same thing. I don't know what you said, but still it's counting hey for 10 seconds. And then this is hey who is sleeping. So Nana is basically I don't know why I did it, but time dot sleep I just using the print statement itself. So it's just printing none because it doesn't have anything right now. So if that is the scenario, then yes, we're this process is actually this first process which we started way back for 10 second back. Meanwhile, it's actually started working for others, and like for Shana, it's still running, right? And then okay, this is the way. This is Shana who's sleeping. None again because I have a time not sleep there. So this is actually what we want for right now, but not exactly, because there are a lot of stuff that we need to still deal with, because there may be functions. So there are categories that we're going to define, like one which are completely independent on each other. Second, they're running parallelly, but they are kind of the same functions, and they should not interact with each other or should wait for one to complete, or that would be third category, that one need to be complete then the second should run. So queue pipes, that that need in those scenarios is gonna need. The second thing that I want to tell you, pjoin in this scenario we are not supposed to use it, but for speech responses, this is like a speech request. You're going to say and you're going to request for some functionality to be performed. But if you talk about speech responses where the system says a response back to you, like for example, you ask for do I need umbrella, and then you ask for you get a response, right? It can be yes or it can be no. and then you just meanwhile you just ask for start a stopwatch for like 20 minutes, so there is a speech response. So it would be a problem if you do the current count for a speech response, like for every second it's counting one, two, three, like that. That would be a problem because these two, either if you start 20 minutes first, 20 minutes stopwatch first, it's actually going to wait for 20 minutes to deal with it and then run it. If you use pjoin, then it will happen. If you don't use it, two instances of the same function will be started, and you'll get a mixed version of speech response. Like it's counting time also, and it speaks yes and no meanwhile in the middle way. So that would be a big problem. And you don't even get what exactly what exactly it says. So first of all, it's way better that you don't put your speech response in somewhere stuck. It doesn't sound good. So if you have a speech response and you have an interaction level of speech response only for those functions, or you can actually, rather than going for a pjoin, not for every instance, but for pjoin, we can do this way that for the for the upcoming task which is active, or for the recent process that have been started, for that you ask for the speech response, and if a new process is started, then kill the previous one and give a speech response for the recent one. That is the one logic that I'm going to try to implement in upcoming weeks. But this will actually help you for for the count time. You don't want it now because you asked for the umbrella, and it's going to cut down the counter, and it's going to give you a response for umbrella. And once that is done, it's going to shut his mouth. And once the counter is completed, or I ask for what is the stage of the counter, then it's going to reply, okay, I was counting and it went to this situation, which is just like hypothetical right now. But this is actually a better way to implement. So use speech responses for the active process, or for the recent speech response request that you asked for, not response, request, the recent speech request that you did for, then it would be a way better. So this is what I'm going to try to implement up for the upcoming week, hopefully. And once that is done, I'll come back with a new video. That would be a part 7 of this tutorials. So that's all. Thank you. I'll try to push this on the same GitHub link. So once that is done, I'm gonna comment the link below the video for your reference. Thank you.